Today we are going back to the mole. Remember what a mole is for. Chemists use the mole to count really small things like atoms. Remember, you can't see one single atom, but we can see 6.02 times 10 to the 23 atoms. The mole is a unit that the chemists use so that we are able to use it and see it when we are doing experiments in the lab. Well, today we are going to review Avogadro's number, which is 6.02 times 10 to the 23. But today's focus will be on molar mass, the mass of 1 mole of a substance. Let's take a look at these pictures. In the image to the right, you have a dozen eggs, a dozen roses, and a dozen donuts. Well, what is a dozen? How many of each item do you have? Right, you have 12. You have 12 eggs, 12 donuts, 12 roses. That's what a dozen means. Well, would a dozen of each object have the same mass? In other words, would they weigh the same? No, they wouldn't. You know that the dozen donuts is probably lighter than the dozen eggs and the dozen roses. So then let's talk about chemistry. Suppose you have a dozen carbon atoms, a dozen gold atoms, and a dozen iron atoms. Even though you have the same number of each, would you expect them all to have the same mass? If you said no, you're correct. They're all different substances. So when counting roses, eggs, or donuts, a dozen is a good unit to use. But if you're counting atoms, a dozen doesn't help much at all, right? Since atoms are so tiny, we use a unit called the mole. A mole represents a macroscopic quantity of matter that can be used in the lab. 1 mole of any element has the same mass in grams as its atomic mass in AMU. Now remember, we learned that in the beginning of the year. We learned about average atomic mass. How did we determine the average atomic mass? For example, what is the average mass of a gold atom? You look at the periodic table, you find gold, and there you have the mass. We learned that previously as the average atomic mass. So in this case, gold's average mass is 196.967 AMU. Well, we're not talking about average atomic mass anymore because we're not talking about one single atom of gold, but now we're talking about 1 mole of gold. We want to know what the mass is in grams of 1 mole of gold. And when we say 1 mole of gold, remember that we're talking about 6.02 times 10 to the 23 atoms of gold. That is 1 mole. So the mass is actually the same thing as the average atomic mass, 196.967 grams of gold is equal to 1 mole of gold. While the number of atoms in a mole is constant, the number of grams in a mole changes based on the element. So for example, take these 3 elements here, sulfur, copper, and carbon. 1 mole of sulfur is equal to 6.02 times 10 to the 23 atoms. 1 mole of copper is equal to 6.02 times 10 to the 23 atoms. 1 mole of carbon is equal to 6.02 times 10 to the 23 atoms. So the number of atoms in a mole is constant, but the mass is different. The number of grams in a mole is known as its molar mass. The units are grams per mole. That many grams equal to 1 mole. And it has the same numerical value as an element's atomic mass, which we learned previously as the average atomic mass with the units of AMU. Using your periodic table, we're going to determine the mass of 1 mole of each of these substances. So find sulfur on your periodic table. 1 mole of sulfur has a mass of 32.06 AMU. Therefore, the molar mass is 32.06 grams per mole. So the molar mass is the mass of the substance that is equal to 1 mole of that substance. So when we write grams per mole, This is actually saying that there are 32.06 grams that's equal to 1 mole of sulfur. Okay, so grams per mole. Now sometimes the masses on your periodic table will have 5, 6, 7 numbers. So that we are consistent, we're going to round the masses from the periodic table to the 100th decimal place, so the second place after the decimal. Okay, so 1 mole of copper, according to our periodic table, is 63.546. I'm going to take that number to the 100th place. If I need to round up, you're going to round up. So copper has a mass of 63.55 AMU. Therefore, the molar mass is 63.55 grams per mole. Go ahead and find carbon. Round the mass to the 100th place. Carbon has a mass of 12.01 AMU. Therefore, the molar mass is 12.01 grams per mole. Now, what if we have a compound? Like, for example, iron 2 chloride, FeCl2. Well, you have to consider the number of atoms of each element within that substance. So for iron 2 chloride, how many iron atoms do we have in FeCl2? We have 1. How about chlorine atoms? We have 2. What is the mass of 1 iron atom? Remember that you need to look at your periodic table to find iron's mass. Iron has a mass of 55.85 grams per mole. Well, what about chlorine? Chlorine, for just 1 chlorine, has a mass of 35.45 grams per mole. So let's find the sum of their masses. Now keep in mind that there's 1 iron atom and 2 chlorine atoms. So we're going to add up 55.85 plus 35.45 times 2 because of the 2 chlorine atoms. So what do you get for the molar mass of FeCl2? You should have gotten 126.75 grams per mole. So what do we do with molar mass? We use the molar mass to convert moles to grams. In a lab, when we're doing experiments, there's no way to measure a mole, but there are ways to measure grams, and that's the mass. And so previously we learned the conversion factor that 1 mole is equal to 6.02 times 10 to the 23 particles. And there were different words for particles, right? Atoms, molecules, ions, formula units. They all meant the same thing when it came to particles that are equal to a mole. Well, now that we learned about covalent substances and ionic compounds, the word molecule is used for covalent substances, and the word formula units are used for ionic compounds. And you guys know by now what atoms are and ions are, and particle is a general term for any of these substances. And then now the second conversion factor you guys know about is that 1 mole is equal to grams, mass of a substance. And that is known as molar mass. We get that by using the periodic table. So let's take a look at some of these practice problems, and we're going to convert between these units. Now take the time to calculate the molar mass of each of these substances. Make sure you are looking at your periodic table. You are rounding the mass to the 100th place so that we are consistent with each other. And don't forget to consider the amount of atoms for each element. So for example, Cu2O, remember that you need to consider 2 coppers and 1 oxygen. And you are adding all the masses to get your molar mass. So pause the video here and calculate the molar masses of each of these 3 compounds. These are the molar masses you should have gotten. Cu2O has a molar mass of 143.10 grams per mole. KMnO4 has a molar mass of 158.04 grams per mole. Nickel 2 nitrate has a molar mass of 182.71 grams per mole. If you got these, great. If you didn't, I'm going to explain how I got these molar masses. Now, if you got these molar masses, feel free to fast forward to the next section of the video. So for Cu2O, there are 2 coppers and 1 oxygen. Each copper is 63.55 grams per mole, according to the periodic table, and we have 2 of them, and oxygen has a mass of 16. So when you add these up, you get 143.10. For a KMnO4, K, there's 1 of them, and that has a mass of 39.10. Mn, there's only 1 manganese that has a mass of 54.94. And for oxygen, there's 4 of them, and we multiply that by the mass of each oxygen, which is 16, and again, you add them up and you get 158.04. Now for this one, nickel 2 nitrate, let's first count the number of atoms in each element. So for nickel, we have 1. For nitrogen, how many do we have? If you take a look, there are parentheses around the NO3. Now think about your math class. What do we usually do when there are parentheses? We distribute, right? And so that 2 gets distributed to everything in the inside. And what do you do mathematically when it gets distributed? You multiply. So nitrogen, there's 1 of them, but we multiply by 2. So we have 2 total nitrogens. And for oxygen, we have 3 in the inside, but again, you multiply by 2 for a total of 6. And so for nickel, we have a mass of 58.69. For nitrogen, you have a mass of 14.01 for each nitrogen. And for oxygen, you have a mass of 16 for each oxygen, which then you would multiply by 6. And again, you are getting the sum of all of this together, and that's how we get 182.71. So if you did not get these masses, try it again using your calculator. This is an important step before we move on with the rest of our notes. For each of these practice problems, we're going to set it up using the fence, also known as dimensional analysis. Remember that this is an important step because this is also a way to show me your work. And then don't forget to use proper units. So problem number 1. How many moles are in 9.15 times 10 to the 26 formula units of aluminum chloride? Now for each of these problems, I want you to think about what you are given and what the problem is asking you to find. So in this first problem, you are given formula units and you are asked to find the number of moles. Now this is important. It's always important whenever you are given a math problem, but this is important for these fence problems because it will basically determine how to set up your fence. So we begin with formula units and it wants moles. So that's where we're headed. And we are going to replace that arrow with the fence. Now you don't have to draw the arrow, you can imagine the arrow, but I think it gives a good visual of where you're trying to go or the path that you're trying to go. And you replace that with the fence, and diagonally you just copy down your previous unit. All right? These are steps that we've talked about before. Now remember that this next fence here, it is a conversion factor, or in other words, a ratio. And previously, the conversion factor we talked about with mole and formula unit is that 1 mole is equal to 6.02 times 10 to the 23 formula units. So where do those numbers go? We'll say it again. 1 mole is equal to 6.02 times 10 to the 23 formula units. You write the number next to the unit, right? So 1 goes next to the unit mole, and 6.02 times 10 to the 23 goes next to the unit formula unit. This way, our diagonal units cancel out, and you multiply across and divide by whatever's on the bottom, and you get an answer of 1.52 times 10 to the 3. Now I'm rounding all of my answers so that I have a total of 3 numbers. And so here I turned it into scientific notation, but if you're not familiar with that, I know we learned about it previously, but again, if you're not familiar with that, you could write the answer as 1,520 moles. It's the same thing. Now, depending on the calculator that you're using, you have to remember to use parentheses in your denominator, or you may need to use the E function on your calculator, and we can talk more about that in class. And if you have questions about your own calculator, I can answer those questions for you, or I can help you with your calculator. Let's take a look at the second problem. What is the mass of 10.0 moles of sulfur? So what are you given? You're given moles of sulfur, and it's asking for mass. Remember that the unit for mass is grams. So you are given moles, and where are we trying to go? We're trying to go to grams. And so there's my path. I'm going to replace the arrow with a fence. Diagonally, I am just copying down the unit, and now I need to fill in my conversion factor or my ratio. So here I have grams over moles, grams of sulfur over moles of sulfur. Well, what are those units? Didn't we just go over that? Those units represent molar mass. So I need to find the molar mass of sulfur from the periodic table. So the molar mass of sulfur is 32.06 grams per mole. 32.06 grams equals 1 mole. So where do those numbers go? 32.06 will go next to my unit grams, and then 1 will go next to my unit mole. My moles cancel out. I multiply across and divide by whatever's on the bottom. So 10 times 32.06 divided by 1 is equal to 320.6 grams of sulfur. And again, I'm going to round that so that I just have a total of 3 numbers, so 321 grams of sulfur. Make sure you are putting these numbers into your calculator as well, so that you know you are doing the math portion correctly. Try the next one on your own. Pause the video and then play when you're ready. So what are you given? You're given 27.4 grams of copper 1 oxide, and it wants moles. So given grams, we're going to moles. Replace that with the fence, bring down your unit, and what's going to go into your second fence. If you put the molar mass of copper 1 oxide in there, great. And you'll notice that you actually calculated the molar mass for this already in your previous slide. So we said that the molar mass of Cu2O is 143.10. So where does that go? 143.10 goes next to grams, 1 mole. So 1 goes next to mole, that goes on top this time. My grams cancel out. Multiply 27.4 times 1 divided by 143.10 is equal to 0.191 moles of Cu2O. Let's take a look at the next one. You are given 66 grams of Cu2O. It wants formula units. Well, if you're given grams of Cu2O, can you go straight to formula units? I want you to think about the diagram or the picture of the mole that I showed you previously. What is always in the middle? According to that diagram or that picture, can you go straight from grams to formula units? No, right? What's always in the middle? The mole is in the middle. So in this case, given grams, you have to go through the mole, and then you can find formula units of this substance. We're going to replace those arrows with the fence, and you can see that we have a total of 2 fences. So that picture that I'm showing you before we get to this fence, this one here, this is showing you how to set up the top part of the fence. Most students find that part the most difficult part of these problems. What will go into the top of the fence? Because the bottom of the fence, that's easy, right? You're just copying down the previous unit. So grams of Cu2O gets copied down. Moles of Cu2O gets copied down. But again, it's the top part that could be the most confusing. But if you visualize that mole picture, and you know that the mole is in the middle, then that gives you the correct setup for the top part of your fence. So now all we have to do is complete the setup using numbers. So we see moles over G. Well, whenever you see those units, even though this time it looks flipped, that is molar mass. That's G right there, molar mass. So what's the molar mass of Cu2O? We found it previously. We even did it in our previous problem. It's 143.10 grams per mole. So I'm going to write 143.10 next to G and 1 next to mole. Now let's complete our last part. How many formula units is equal to how many moles? What's that conversion factor? 1 mole is equal to 6.02 times 10 to the 23 formula units. Our grams cancel out, moles cancel out. So multiply 66 times 1 times 6.02 times 10 to the 23. Divide that by 143.10. What do you get? You should have gotten 2.78 times 10 to the 23 formula units Cu2O. Again, take the time to use your calculator to get this answer. It is important that you are following along with your calculator. Feel free to pause the video anytime so that you can try these problems on your own. Let's take a look at the next problem. How many molecules are in 3.81 grams of KMnO4? So given grams, now it's asking for molecules. So given grams, can we go straight to molecules? No. You have to go through the moles and then you can find the molecules. So we're going to replace that with the fence, copy down the unit to the bottom of the fence, and then we're going to fill it in with numbers. We found the molar mass of KMnO4 previously. We know the molar mass is 158.04 grams per mole. So where do those numbers go? 1 will go next to mole, and 158.04 grams goes on the bottom. Molecules over mole. How many molecules is equal to how many moles? 1 mole is equal to 6.02 times 10 to the 23 molecules. Grams cancel out, moles cancel out, multiply across, divide by whatever number is on the bottom, and you should get an answer of 1.45 times 10 to the 22 molecules of KMnO4. Last problem. What are you given? You're given atoms of carbon, and it's asking for mass. Remember, mass is grams. So given atoms, remember you can't go straight to grams. You have to go through the mole. Again, imagine the picture, the diagram. And then you can go to grams. Replace that with the fence. Copy the unit down. And then fill in your conversion factors or your fences or your ratios. How many moles is equal to how many atoms? 1 mole is equal to 6.02 times 10 to the 23 atoms. How many grams is equal to how many moles? What is that? That's molar mass. Find carbon. Carbon's molar mass is 12.01 grams per mole. So where do those numbers go? 12.01 will go on top next to grams. 1 will go next to mole. Atoms cancel out. Moles cancel out. Multiply across. Divide by Avogadro's number. And you get an answer of 239 grams of carbon.